All right, hello again, pre-calculus people. So in today's video, we're going to be talking about, it's basically going to be part 2 of what we did last week, using this thing called the rational root test to find zeros of polynomial functions. Now, last week, I did a video on just how to make a list of possible zeros. I'll link to that video at the end of this one. Today, we're going to be using that list to see how we can figure out what is a zero, and then actually solving the whole polynomial to find all of the zeros that are in there. Okay, so what this is going to involve is a couple things. So first, obviously making that list, which we did last week. It's also going to involve knowing how to divide polynomials. Now, I'm going to use long division in this video. If you know synthetic division, that will certainly work too. And you can do it that way, but I'm going to use long division. There's no real difference in how long it takes, so I'm just going to use long division. And then it's also going to involve this thing called the remainder theorem. Now, what the remainder theorem says, I kind of wrote it out here, but basically what it says is if you want to test a factor or test a number to see if it's a zero, you can just plug that number in. And if it is in fact going to be a zero, then we can immediately know what the factor is. In other words, remainder theorem says if you do the division and the remainder you get, that number is the same as if you plugged that number into the function. So that's kind of a nice little shortcut that we're going to use. So let's take a look and see what this process is going to look like. So this is an example that I did with the couple days ago on making the list of possible zeros. So here's our whole list. So the remainder theorem says that I can just start plugging numbers in. And once I find one that equals 0, then I know I have a root, and I can use that root to find the other roots. Okay, so let's go and do that. So let's go and plug in 1 for all of the x's of my function. So f of 1 is going to be 3 times 1 to the third plus 1 times x to the 1 to the squared minus 12 times 1 minus 4. And if you work that out, that's 3 plus 1 is 4. 4 minus 12 is negative 8. And then negative 8 minus 4 is negative 12. Doesn't work. Again, all we care about is if it's equal to 0. So if it doesn't equal 0, I don't care. Moving on. Check the next one. How about negative 1? 3 times negative 1 to the third plus negative 1 squared minus 12 times negative 1 minus 4. And again, watch your sign. So this is negative 3 plus 1, which is negative 2. Negative 2 plus 12 is 10. 10 minus 4 is 6. Again, not 0. So moving on. How about the next one? F of 2. So again, plug that 2 in everywhere. And look what happens here. 2 to the third is 8. 8 times 3 is 24. Plus 4 is 28. But then I subtract 24 and subtract 4. So that does come out to be 0. And that is what we want, right? So what that means is x equals 2 is a root. And that also means, with the remainder theorem, that also means that x minus 2, notice the sign change, is a factor. Okay, now you might be thinking, well, are we done? Is that the whole problem? No, because there's something called the fundamental theorem of algebra that says if you look at the highest exponent of a polynomial, in this case 3, that means this has 3 roots. So we found one of them, which is awesome, but now we got to find the other 2. So what we're going to do with this is where the division comes in. So I'm going to take this factor and divide it into the original function, and then basically reduce that to see what's left over, and then solve that. So let's do that. So we're going to do x minus 2 into 3x to the third plus x squared minus 12x minus 4. Okay, and again, you should know how to do this. I'm going to zip through this pretty quickly. I will link to the division video at the end of this one. So that's going to be 3x squared. Don't forget to distribute. And it comes straight down. Same thing. So plus 7x. Distribute. Change the sign. Bring that straight down. We multiply by 2. Again, distribute. And sure enough, happy days. This whole thing cancels, giving us a remainder of 0, which we knew that was going to happen because of the remainder theorem up here. But we don't care about that because we already knew that. But what we care about is what's left over, because we have now reduced this third degree polynomial to a quadratic. Okay, so now I'm going to take this quadratic and I'm going to solve that. And we have different methods to do that. Obviously, if it's factorable, or the quadratic formula, or what have you. So I'm going to take what's left over there, set that equal to 0, and solve from there. Now, this one is factorable. Not all of them will be factorable, but now I can just factor that like I would any quadratic. Different methods available here. So I can do the AC method and then factor that. To 1 6. We need to go back and redivide by 3. So that means we're going to have 3x plus 1 and x plus 2 as our factored quadratic, which means x would be equal to negative 1/3 and x would be equal to negative 2. So now I can take what I found in this first step. So I knew that x equals 2 is a root, and I know that these two guys are my roots. So now I'm done because, again, I know I'm going to have 3 of them. So x equals 2, negative 2, and negative 1/3 are my roots of the polynomial. Okay. Now, I'm going to go and do one more example, but just like anything else I talk about, especially in upper level math, I'm really only going to do one more because after that, you have to know kind of what the process is, because the process is always the same. Now, the next one I'm going to do is going to be a 4th degree. So the highest exponent is going to be 4. So those are going to be a little bit longer because even when I find the first root and divide, I'm still going to have a cubic left. And then I'll have to divide again to get it down to a quadratic. Once you're at the quadratic stage, then you have tools available to you. But before you get to that stage, it's kind of going to be a trial and error thing. Okay, so let's take a look and see what that looks like. So here is your 4th degree polynomial that we're going to do. Okay, so again, this one's nice because the leading coefficient is just 1, so my whole list are just plain old integers. Okay, but again, I need to find one that gives me a 0. So I'm going to start with the beginning. Might as well plug in the easy one. So let's find out what f of 1 is. So plug all those in. And if you see here, that's 1 plus 2 is 3. 3 minus 7 is negative 4. Negative 4 minus 8 is negative 12. Plus 12. Oh, good. Look at there. Happy days, because the first one we checked is a 0. So that's always nice. So that means x equals 1 is a root. So that's one of the four. Remember, there's going to be four of them total because of that biggest exponent. And that also means x minus 1 is a factor. Okay. Now we have to divide, right? So again, we're going to take x minus 1, divide it into our original. Okay, and start dividing. So x into x to the third, x to the fourth. And that's going to be 3x to the third. Don't forget to change signs. That's 3x squared, x into 3x to the third. And again, watch your signs. This is going to be a negative 4x squared. X into negative 4x squared. That's going to be negative 12x. So x into negative 12x is a minus 12. And happy days. Again, we don't want that because we knew it was going to be remainder 0, but we're glad that it happened because that means this is what we have left, and now we can kind of repeat the process. Okay, so I'm going to write this down here. So we got x to the third plus 3x squared minus 4x minus 12. Okay, and now we can go back to our same list that we had before, and again, check to see which of these will make that equal to 0. Okay, now the catch is we do need to recheck 1 again because the roots may repeat. That is a thing. So I'm going to plug in 1 again to make sure it doesn't to make sure that that root doesn't repeat itself. So 1 to the third plus 3, 1 squared, that's 4 times 1 minus 12. Oops. So you got 1 plus 3 is 4. 4 minus 4 is 0, but minus 12, so that's equal to minus 12. So nope, it does not repeat. So we move on. How about negative 1? And again, I'm plugging it into that thing I have left over, my reduced polynomial, as it were. So negative 1 to the third. And that's going to be negative 1 plus 3, which is 2. 2 plus 4 is 6. 6 minus 12 is negative 6, so that doesn't work either. Let's go to 2. And let's see, so we got 8. 4 times 3 is 12, so 8 plus 12 is 20. But then minus 8 minus 12, that does equal to 0. So again, happy days. That means x equals 2 is a root. That's our second root. And x minus 2 is another factor. Okay, now we have to divide again. So I'm going to take x minus 2, divide it into my reduced function, and do that one more time. So x minus 2, x to the third, 3x squared, minus 4x, minus 12. So x and x cubed, distribute. That'd be 5x squared. Bring that down. X into 5x squared. Minus 10x. And that's going to be 6x minus 12. And then plus 6, which is 6x minus 12. And when you subtract, everything cancels, which is definitely what we expected. So all we need from here, and I apologize, I dropped my pen, is I take my answer, and lo and behold, now I have my quadratic. I'm going to write this over here. So x squared plus 5x plus 6, which again can be factored. Your quadratic will not always be able to be factored, but again, we have our quadratic formula to use when that happens. So this is a straightforward one. This is just x plus 3 and x plus 2. So x equals -3 and x equals -2. So we take all of those that I found. So the first one that I found was x equals 1. And then I found x equals 2. And then I found the -3 and the -2. So my zeros for that whole polynomial, x equals 1, 2, -2, and -3. By the way, you could also write this in factored form. So if you take all of those different factors, I could write that polynomial as x minus 1 times x minus 2 times x plus 3 times x plus 2. And that is okay too. But this is what we're looking for, the zeros of the polynomial. So that is the whole process of the rational root test. You are going to have plenty of time to practice this and kind of get better at it so your speed improves also. But as always, if you need some help, come into tutoring, ask some questions during class. Until next time, stay safe.